Question number 1.
B.
Shows the diagram, height of blah, 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 identical coins. What is the thickness of one coin? So basically, you're supposed to count how many coins are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. So you divide by 12 lah, right? And you'll get an answer. What's the answer?
0.2 cm, then 2 mm now.
It will be 0.2 cm, which is basically going to be 2 mm points. Excellent. Good job. 4 balls with different masses are dropped at the same height. Guys, keyword here is that air resistance may be ignored. If air resistance is ignored, that means to say the only thing that's acting on all of the balls are gravity. And gravity is the one that accelerates the ball downwards, right? P has the greatest acceleration. No, they have the same gravity. Q and R takes the same time to land on the ground. You really wrote this,
Wait.
Q and R.
Oh shit.
Bloody hell.
I thought it's the moon.
Which world are we in right now? The acceleration of R is half the acceleration of P. No, they all have the same acceleration. Ball S has the greatest average speed, which makes sense because this thing has the longest time to accelerate, right? Based on the height. The answer is not P.
But they all have the same.
Yes.
Even though they have different mass power.
Yes.
Why?
Because they're all acted by the same gravity.
So actually they fall at the same time, just that they take longer to fall.
Yeah. An object is traveling in a straight line. The diagram is the speed time graph of an object at which label point is the object accelerating at a changing rate. Accelerating at a changing rate means to say there is a change in the gradient, which is obviously going to be B for this scenario here. Right. Which statement about the masses and weight of the object on Earth is correct? A balance can be used to measure to compare the weight, not masses. Definitely no. Heavy objects always have more mass than light objects. Logical. Large objects have more mass. No. Large mass is the force, but weight is not. No.
Correct.
Answer is only point. Okay. An object in space probe on Earth. What? An object in a space probe above Earth weighs 3.5 newtons. The gravitational field of the height at the space probe is this amount. This is gravity and this is the weight. The gravitational field strength of Earth is this amount. This is the gravity of Earth. This is the gravity of the space probe, right? What is the mass and weight of the object on Earth's surface? So basically you have to find your mass here first, right? Right, W equals to mg. M will be equal to W over G, which in this case here will 3.5 divided by 7. So it's for sure either one of these two already, right? Then after that, you're looking for the weight on Earth, W equals to mg, which in this case 0.5 times 10, which is going to be a B. Okay? A skydiver jumps from a stationary helicopter and reaches a steady vertical speed. She then opens her parachute. Yeah, I think we talked about this already, right? Answer is A, guys. As the parachute opens, the acceleration is upwards. Imagine the guy is falling downwards, but he'll acceleration upwards, which causes him to decelerate and thus slow down in terms of his speed, guys. And that's what we want, right? If not, you're going to land on the ground and die. So A is definitely the answer here. This question, for those who got it wrong, you can consider yourself GG out already, especially those who were here for a long time. As soon as you see anything that's moving in a circular motion, that means to say what? It's towards the center of the circle, right? What is towards the center of the circle? Resultant force and? Acceleration. So any other answer is absolutely unacceptable, guys. It's either you have not been paying attention or you are just GG. I cannot have any other word. By the way, this is 3 marks, guys. If you got this wrong, you better think again. Yeah, for sure. Okay. A moving body undergoes a change of momentum. What is the change of momentum? Either Ft equals to mv minus mu, right? So it's either Newton second or kgs meters per second, right? Either one.
What?
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 Surprising? Okay. Yeah, this question is a very interesting question, which a lot of students have already kind of struggled a little bit. Okay, pay attention. This one is an interesting question. A man either takes an escalator or lift to travel up between two floors in a hotel. The escalator takes 20 seconds to carry a man between the two floors. The useful work done against gravity is W. Against gravity means to say this is the direction of W, right? The useful power it develops is P. Okay. So from here, you can kind of imagine that power is equals to work done over 20 in this scenario, right? Based on the information. Definitely is. Work done is in joules. Okay. Now after that, it says the lift takes 30 seconds. This guy takes 30 seconds. Carrying the same man, which obviously has the same weight, right? Between the same two floors, which have the same height as well, right? So from here, since the weight is assumed to be the same because it's the same man, right? And they're traveling the exact same height, right? So I will assume that the energy needed is going to be the same. So from here, they ask you, what is the useful work done against gravity by the lift? By the lift, same W, right? Because it's the same man, right?
Less than.
What about the power? Will it be more or less?
Less than.
It's less. Why? Why? Because power is equals to energy over time. A higher time means to say a lower power is needed, guys. Right, so that's why answer is going to be C.
Oh, because the one is same because the distance the same.
Yeah, the weight of the man is the same.
Yeah.
Yep. Okay, then after that, 40 watts lamp wasted 36 joules every second. What is the efficiency? Huh? It's 6 over 40, guys, because this is wasted. Right, and obviously your answer will be 15% times 100. Okay, and this one, straightforward, nothing to explain, rho GH. Okay, question 12, ignore. Question 13, which we already did last week. What's the answer?
B.
Yeah.
But the one answer
What do you mean?
like the one answer I pull out like it's improbable.
You thought that this one was improbable?
I don't know.
But maybe.
Last week discussed with the Brownian function.
Anyways, at negative 39 degrees Celsius, mercury solidifies without a change in temperature, which rho shows whether the mercury absorbs or release energy. With solidifying, obviously it is releasing energy for sure, and the bonds between the atom becomes stronger.
This is more chemistry question.
Yeah, this has actually been removed to chemistry already. In which type of the substance are free electrons involved in the transfer of thermal energy? All liquids, all solids, metals only, or plastic only?
C.
Yeah. This one.
A.
A.
Yeah.
Oh, so it's A.
So we're trying to do
A.
both.
A.
What is it? A or C?
A.
Chinese reflect.
Tau is the best emitter of heat, and obviously you want to have a larger surface area to emit as much heat as possible, right? And thus the answer is A. This is also a very interesting question, which, how do you know?
B is too much, B is too less.
What the?
C, yeah.
B and A is
What about in terms of calculation? How do you do it?
I don't.
A person uses a surfboard to ride every 30th wave. So after there's let's say there's a 30th wave, he rides this 30th one. The wave travels at a speed of 1.6 meters per second, right? And the distance between each wave crest is 24 meters. How many wave crests does the person surf in 1 hour? So first and foremost, I want to know
30 times 24 times 1.6.
I don't know.
Yeah, 30 times 24 Because 30 times 24, why? Why do we do 30 times 24 first?
The distance of the
Yeah,
30
this is the distance for each wave that this person surfs on. So this one you press in the calculator, you'll get 720. Yeah, you get 720 here. Yeah, this is the distance for each wave that he surfs, right? And since the speed is 1.6 meters per second, right? What do we do next? Let's divide. Why? Speed equals the distance over time, guys. So time would be 720 divided by your speed, which is 1.6. Whatever answer this is, what answer will this be? Huh? 450 seconds. It takes 450 seconds to ride 1/30th wave.
Okay, so I think when before I heard you do that with
This is the distance.
I thought you only serve 30 consecutive times per life. Then I look at this cycle. Every 30 times you only serve one.
Yeah, that's correct. So the distance between each 30th wave is 720 meters. And since the speed of the wave is 1.6 meters per second, each time taken to reach the 30th wave is 450 seconds. Does this make sense or not? Right. So 1 hour for how many seconds? Divide by 60. No. 1 hour for how many seconds?
60? No. 60 times 60. 3,600.
1 hour, that's 3,600 seconds. So if each one of these 30th wave takes 450 seconds, I just divide by 450, right? And I'll get something.
8.
8. Oh, okay. You say.
I think it's 8.
Ah,
Mental calculation.
yeah, it's 8. Okay. Okay, ladies and gentlemen.
Also the colors.
20. In a shallow tank, the water moves towards the barrier with a narrow gap. The diagram shows the wave beyond the barrier. What's the condition? What's this phenomena called again? Diffraction. What's the condition for diffraction to occur more? The wavelength must be very good, bigger than the gap. So right now it seems like this wavelength is bigger than this gap, right? So more or less diffraction. Yeah, definitely not key. Light passes along optical fiber. What happens to the light within the fiber? This one, anyone got it wrong?
Me.
What do you say? It's for sure total internal reflection.
What's 8?
Shut up. Shut up. The point labeled F as principal foci, blah, 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 which diagram shows the path after it passes through the lens. Guys, by very definition itself, our focus point is where all the light rays focus upon focal point. Right, so answer can be no other than point. Everything else doesn't make sense. Which statement about sound wave is correct? They travel through the vacuum, definitely no. They travel through solids, yes. They are transverse wave, no. They travel at the same speed in all substances, no. But which statement about ultrasound is correct?
I guess 8.
Yeah. You can't hear it. It's greater than how many? How much is ultrasound? It's greater than 20,000 hertz. And it's not traveling in vacuum.
And here, due to the yeah, I'm playing over the
Don't you know this?
Next,
a small compass is placed close to a strong bar magnet. The distance from each end shows the diagram of the needle. Guys, once again, I want to emphasize that a strong magnet will influence the direction of a weak magnet, right? And in this case here, since the strong magnet's magnetic field looks something like this, Then obviously the answer must be C, right? Cannot be any other answer. B, north pointing towards the north.
One segment.
That's the problem, isn't it? Which particle moves in metal called this one? So if you get this wrong, you can consider no. The diagram represents 4 copper wires. Which one has the greatest resistance? What's the formula for resistance in a wire again? Length over area. I must have high length and small area, right? Which only C is the only one.
All correct, all correct.
29, I think it's A lah. But let's see.
Confirm.
Yeah, it's A. 29 is A is because all the electrical energy is converted outwards. For example, electrical energy is converted into heat energy. The electrical energy is converted to light and heat. And electrical fire is also same thing, light and heat. 4 circuits are set up. In which circuit does the ammeter show the greatest reading?
A.
The one with the smallest resistance.
A.
Yeah. Is it?
1/2 plus 1/3 now.
Yeah, 1/2 plus 1/3, which is 5/6,
6/5.
which is 1.2 ohms. This one,
1/2.
This one is 3 ohms. This one, This one is 0 ohms, 0 here. This one, 2 ohms. Yeah, this one has the smallest resistance, guys. Anyone don't know how to calculate this? Good luck. Okay. The diagram shows an electrical circuit. The light falling on the light-dependent resistor increases. If I have light intensity increasing, what happens to the light-dependent resistor? More? Oh, yeah, very good. It's a lower resistance. What happens to the resistance of the LDR, the current in the fixed resistor, and reading on the voltmeter? So first and foremost, the light-dependent resistor definitely decreases, right? And because the total resistance here decrease, the current will definitely increase. And right now, the resistance here is lower compared to the resistance here. What happens to those voltmeter here?
Decrease.
Decrease? You say decrease? You increase. You
Increase.
you increase or decrease? Increase you? Increase you? Increase you? Decrease. You? Decrease you? Increase or decrease? Up or down? Down. You? The answer is increased. Why? Guys, listen up. Right now, right, what's happening here? This thing has lowered resistance, right? And this thing will be relatively higher resistance already. Relatively means to say compared to this. And when this thing has comparatively more resistance, it will actually take in more or less volts. More. And since this is in parallel, if I have more volts here, it means to say I'll have more volts here also, right? And thus your answer should be increased. Is this the last question?
Yeah.
The diagram shows 2 link circuits controlled when a bell is switched on. The conditions are altered and one pair of condition cause the bell to ring. Which one?
A.
Oh. So, hey, by the way, guys, this is an electromagnet. In order for this electromagnet to be a magnet, there must be current flowing through it, right? Right, so if I want current to flow through it, the resistance here must be low. So this one is a light-dependent resistor, right? Light intensity must be high. What's this thing called again?
Thermistor.
Thermistor. The temperature should be Decrease.
High.
High. So that the resistance is low once again. So bright high, temperature high. Ta-da.
Extra class.
That'll be for today, guys.
Extra class.
All next week. I mean, yes, next week's for online. And next year. Sorry, next week no class.
So you want me to come on?
Next month online, and then next year we resume physical class. Yay! That'll be all for today.